Today in physics electromagnetic induction, now to see one numerical. Numerical is based on magnetic density. The numerical is like this way, just you can see here. Obtain the expression for the magnetic energy stored in terms of magnetic field B, area A and length L of the solenoid. How does the magnetic energy compare with the electrostatic energy stored in capacitor? Now we know that suppose this is a solenoid on length L and area A. Current in this solenoid is suppose I, and now the magnetic field produced in this solenoid is given by B is equal to B0 and I. Therefore, I is equal to B upon A0 into N, equation number 4. Similarly, the self-inductance, that is L is equal to mu 0 N square A into L. This is equation number 3. Now the energy stored in this solenoid is given by that is U B is equal to 1/2 L I square. Now keeping the value of I and L in this equation, we get UB is equal to 1/2 L, that is mu 0 N square AL into I square is B upon mu 0 into N whole square. Now simplifying, we will get here UB is equal to 1/2 this mu 0 N square AL into B square divided by mu 0 square into N square. This N square will be cancelled, one mu will be cancelled. So finally we can get here, that is UB is equal to 1/2 into B square upon mu 0 into AL. Equation number 4. Now the magnetic density is given by, that is magnetic density ρb is equal to UB upon volume is equal to 1/2 B square AL upon mu 0 into volume V. Keeping the value here, that is 1/2 B square AL upon mu 0 into AL. So AL will be cancelled, so finally we can get here 1/2 into mu 0 into B square. So the magnetic density is given by, that is rho B is equal to 1/2 mu 0 into B square. Now comparing with the electrostatic, that is energy density in capacitor is given, the rho E is equal to 1/2 epsilon 0 E square. So both the, we can say that both the magnetic and electrostatic density is directly proportional to the square of their fields, magnetic field or electric field. So this way to understand this numerical. In this numerical solenoid having a length L, number of turns is, that is N, and cross section area A, and the current in this solenoid is I. We know that due to the current, the magnetic field produced in the solenoid B is equal to mu 0 and I therefore is equal to B upon mu 0 into small n, where small n is equal to capital N upon capital L. Now similarly the self inductance is induced here, self inductance is produced by, that is L is equal to mu 0 N square into A into capital L. Now we know that the energy stored in this solenoid is given by, that is UB is equal to 1/2 L into I square. Keeping the value of L and I and simplifying, we will get here, that is UB is equal to 1/2 into B square into AL upon mu 0. Now, this energy stored in this solenoid is divided by the volume, that it will give the magnetic density rho V is equal to UV upon V. Keeping the value and finally solving this, will get 1/2 into V square upon mu 0. Comparing this is a magnetic density, and similarly comparing this electrostatic density capacitor, that is rho E is equal to 1/2 times 0 E square. Both the equation shows that their density is directly proportional to the square of their intensity, magnetic field intensity or electrostatic or electric field intensity. So this will understand this. Thank you.